Okay, so let's get started with this. We covered all the concepts that we have in differentiation in the last session. We started with the idea of differentiation. Why do we need to do this? This is used to find gradients of curves, okay? And differentiation is used to find gradients of curves. This is the notation that we use. Derivative of y is dy over dx. Derivative of f of x is f dash of x. These are the notations that we have. The rule that we apply for differentiation is this: if you have x raised to power n, that becomes nx raised to power n minus 1. If there's any constant multiplying outside, that remains as it is. So there are two things that you do. To find the derivative, you multiply by the power and subtract 1 from the power. Okay. We did some examples of this. Then if you want gradient at a particular point, for example, in this case, if we want the gradient at the point A such that the x coordinate of A is 2, we would find the derivative of the function. In this case, that turned out to be 3x squared. We would just put the value of x in this. The value of x is 2. We input that value of x for the point that we want the gradient at. And then the number that we get from that, that's the gradient of the curve at that particular point. Okay, so to find the gradient at any particular point, you find the derivative and then put the value of x in that derivative. That's what we discussed. We did a number of examples in this. If you have multiple terms in a derivative, you just differentiate, and multiple terms in a function, you just differentiate each term separately. If you have x power 1, then the derivative is just the number that's multiplying outside. If it's a constant, then the derivative is 0. Okay, and that's what we discussed. These are two specific cases that you should be able to write the derivative for directly. Then we talked about the idea of stationary points. Stationary point is just another name for turning points. How do you find turning points? You find the derivative and put that equal to 0. That gives you the x coordinate of the turning point. You put that back in the function to get the corresponding y coordinate. We did this for quadratic function, cubic function. And then if you have to figure out if that turning point is a maximum or a minimum, what you do for that is you find the second derivative. Find the second derivative, put those values of x in that second derivative. If the result turns out to be negative, it's a maximum point. And if the result turns out to be positive, it's a minimum point. Okay, so if the second derivative is positive, you have minimum point. If the second derivative is negative, you have a maximum point. That's what we did. And then finally, we talked about how to find equations of tangents. Equation of a tangent at any particular point for a curve is the same as the gradient of the curve at that point. Let me repeat. Gradient of a tangent at any particular point is the same as the gradient of the curve at that point. So if you want to find equation of a tangent at any particular point, tangent is a straight line. For any straight line, we need two things to be able to write down the equation. One is a point and the other is the gradient. Now, generally a point would be given, and using that point, you would have to find the equation of the tangent. What you do for that is you find the derivative of the function, put that value of x in that, and that will give you the gradient of the curve at that point. Whatever is the gradient of the curve at that point, it will be the same as the gradient of the tangent. So you would have the gradient of the tangent from there. You can write down the equation using the point and the gradient. Y minus y1 equals mn2 x minus x1, and that will give you the equation of that tangent. These are all the concepts that we have in our syllabus. Now let's get to some practice questions, and there's some past paper questions on this. Now, before I start, can you please confirm if my voice is clear for you? Any lag? Or is it okay? All right. Now let's get started with some questions. This is a fairly straightforward one. You have this function 3x squared plus 4x minus 1. You have to find the derivative of this, dy over dx. What would that be? Multiply by 2. So 3 into 2, that becomes 6. Subtract 1 from the power. It becomes x. Derivative of 4x, that's just 4. And you just write that here. 6x plus 4. Derivative of 1 minus 1 is just 0. So you're left with 6x plus 4. That's the derivative of this function. Okay, so that was fairly straightforward. Now you have this function, this equation that says y equals x cubed minus 2x squared plus 5. Find the coordinates of its two stationary points. Now, how do you find stationary points? You find the derivative for that equal to 0. Now, what's the derivative of this function going to be? X cubed multiply by the power, subtract 1 from the power, so it becomes x power 2, minus 2 into 2. What's that? That's 4. Subtract 1 from the power, x power 1. So you have minus 4x. Derivative of 5 is just 0. So this is the derivative. Now you put this equal to 0. Why do we need to do that? Because we are looking for a stationary point. At stationary points, the derivative is supposed to equal 0. So we equate this to 0. This gives us 0 equals 3x squared minus 4x. Now, how do we solve equations like these? We take x common on the right side, and that leaves us with 3x minus 4 inside. We have a product now, x times 3x minus 4, which means either x equals 0 or 3x minus 4 equals 0. The second value of x that we get is 4 over 3. We have these two x coordinates. Now, we wanted the coordinates of the stationary points. That means we also want the y coordinates. So now we can put these values of x back in the function to get the corresponding y values. If I input x equal to 0 in that function, in that original function, what do I get from that? 0 cubed minus 2 into 0 squared plus 5, and that will just be 5. So the first point, therefore, is 0, 5. Input x equals 4 over 3 in that, and you get y equals 4 over 3 whole cube minus 2 into 4 over 3 whole squared plus 5. Now, this is from the calculator paper. So you can just put this whole thing on your calculator and see what that gives you. 4 over 3 whole cube minus 2 times 4 over 3 whole squared plus 5. And that gives me 103 over 27. That's the second value of y that I'm getting. I'll just check my working again because it looks like a weird result. But let's just confirm it is possible. But I'm just going to confirm quickly. 3x minus 4x equals 4 over 3. Have I put this correctly there? 4 over 3 whole cube minus 2 into 4 over 3 whole squared plus 5. Okay, that seems fine. Y equals 1 over 3 over 27. You keep it in this form, in the exact form, and you say the coordinates are 4 over 3 and 103 over 27. This is the other point. You can write them. First point is 0, 5, and the other point is 4 over 3 and 103 divided by 27. These are final answers. Okay. Now, if my voice breaks at any point, please do let me know. I'm on my 4G right now, and it is possible that there is a lag at some point. In case that happens, please do let me know so I can repeat what I said. Okay, let's move on to the next one now. X coordinates of the points on the graph where the gradient is 0. Okay, now how do we think about this? Find the x coordinates of the points on the graph of this function where the gradient is 0. Now, this is a curve. How do you find gradients of curves? Gradients of curves are found using the derivative. So the first thing you do is you find the derivative of this function, dy over dx, and see what that gives you. Dy over dx. X power 5, you multiply by the power, subtract 1 from the power, it becomes 5x raised to power 4 minus 4 into 5, that's 20. Subtract 1 from the power, that's x cubed. This is the derivative. Now we want to find the x coordinates, so we do not know the x coordinates. The x values are not known. We have to find them at the point where the gradient is 0. Now for curves and for any function, you can say gradient basically is represented by dy over dx, right? Derivative represents the gradient. So if the gradient is 0, what that means is the derivative is 0. So what you do here is you put dy over dx equal to 0. Now, this is exactly what we used to do earlier to find stationary points as well, but they have changed their statement here. Instead of saying find the x coordinates of the stationary points, they are saying find the points where the gradient is 0. Now, we have talked about this before. At the point where gradient is 0, the points are supposed to be stationary points. It'll either be like this point here, or like this point here. So they are asking for stationary points, but they're asking it in a different way. Okay. So you just put dy by dx equal to 0 and see what that gives you. 0 equals 5x raised to power 4 minus 20x cube. How do we solve this equation now? We can take 5x cube common from the right side. That leaves us with x minus 4 inside. So either 5x cube equals 0 or x minus 4 equals 0. The first equation gives you x cube equal to 0. 5 goes to the other side, gets divided. And then you take cube root, you get x equal to 0. From the other equation, you get x equal to 4. And these are the x coordinates that we were looking for. They have not asked for the y coordinates. They have specified they just want the x coordinates. So we can write down these final answers. We can say x is either equal to 0 or x is equal to 4. These are the two values of x that we get from this. All right, let's move on. We have this curve. It has this equation. Let me just see how many questions we have coming up. So we can probably try and do all of them. Okay. Let me see if we should do this. Gradient of the curve at this point, coordinates of the turning point. Okay, I'll just do the first part of this. The second part is just stationary points. You'll put dy over dx equal to 0 for that. Okay. What I'm going to do is I'm just going to do the first part of this question. It says find the gradient of the curve at this point. Now, how do you approach this question? Gradients of curves, they are found using the derivative. So that's the first thing you do. You find the derivative of this function. X cube. You multiply by the power, subtract 1 from the power. It becomes 3x squared minus derivative of 12x. That's just 12. And now, since you want the gradient at a particular point, you are given that point. Gradient is what you're looking for. Remember, gradient is represented by dy over dx. So we want to find the value of dy over dx when x is equal to 1 and y is equal to minus 11. What you can do is you can just input x equal to 1 in this case, using that point. Just input that value here. And that will give you the gradient at that particular point for the curve. 3 into 1 squared minus 12. And that gives you minus 9. This is the gradient that we are looking for. That's the gradient of the curve at this particular point. All right, let's move on. Okay, so differentiate that, find the derivative of this basically, and then find the coordinates of the stationary points. Again, you put dy over dx equal to 0. You'll get a quadratic equation. You can solve that. But then you have to determine whether the points are maximum or a minimum. Okay, let me just see if there's another question on maximum minimum later on. So we could skip that one because that's fairly easy. Is there another that requires us to find maximum or minimum? Okay, so not that I can see here. Okay, so what I'll do is I'll do this question quickly as well then, because this is another concept that you need to be able to do. Let's differentiate this function. What's the derivative of x cubed minus 4x squared minus 3x? X cubed, the derivative of that is 3x squared minus 4x squared. Multiply by the power, 4 multiplied by 2. That gives you 8. So minus 8. Subtract 1 from the power. That's just going to be x. Derivative of minus 3x is just minus 3. This is the derivative that we were looking for in the first part. 3x squared minus 8x minus 3. Now it says find the coordinates of the two stationary points. Now I put this equal to 0 because we're looking for stationary points. At stationary points, we know that the derivative is supposed to be equal to 0. So that's what we do. We put the derivative equal to 0 and see what that gives us. 3x squared minus 8x minus 3 equal to 0. Can we factorize this? 3 times 3 is 9. We want to subtract two numbers to get this. Yes, we can do that. 3x squared minus 9x plus x minus 3 equal to 0. So I'm using minus 9 and 1 to break it down. And that gives me two factors, 3x into x minus 3 plus 1 into x minus 3. We get two factors from this, 3x plus 1 and x minus 3. That means either x equals minus 1 over 3 or x equals 3. These are the two x coordinates that I'm getting. What about the corresponding y coordinates? I can input these values of x back in the function to get the corresponding y coordinates. Let's see what they turn out to be. Let's input x equals minus 1 over 3. Then we can input x equals 3. When we input x equals minus 1 over 3, the y value turns out to be minus 1 over 3 whole cube. You have to show this working where you're inputting these values there. Minus 1 over 3 whole cube. Minus 4 into minus 1 over 3 whole squared minus 3 into minus 1 over 3. You can put this thing on your calculator directly. Minus, oops. Minus 1 over 3 whole cube. Minus 4 times minus 1 over 3 whole squared minus 3 times minus 1 over 3. That's giving me 14 over 27. So these are the coordinates of the first stationary point, minus 1 over 3 and 14 over 27. Okay, now what about the other one? You can put x equal to 3 now. The y value turns out to be 3 cube minus 4 into 3 squared minus 3 into 3. And that will give you the result for the second point. 3 cube is 27 minus 4 times 9. That's 36 minus 9. That's minus 18. So this point is minus 18, 3 and minus 18. This is the other point that we have. These are the two stationary points that we were looking for. Now it says determine whether each stationary point is a maximum or a minimum. How do we do this now? Maximum or a minimum? We have to use the second derivative for this, right? We have the first derivative already. We found that here. This is the first derivative. We can differentiate that once more. Let me write that down here. 3x squared minus 8x minus 3. Let's find the derivative of this again. D squared y over dx squared. What's the derivative of this? That's 6x. Minus derivative of 8x, that's minus 8. Now you put those values of x, right? This is in terms of x. We can only know if it's positive or negative once we input those values of x. So one value of x is minus 1 over 3. That's the x coordinate of one stationary point. And then the other stationary point is x equals 3. You input these two values here and see what that gives you. D squared y over dx squared. This is giving me 6 into minus 1 over 3 minus 8. That's minus 2 minus 8. And that's minus 10. This is a negative number. Negative number means we have a maximum point at minus 1 over 3 and 14 over 27. This is a maximum point. Okay. Then what about the case when x is equal to 3? That will most likely turn out to be minimum, but let's show the working for that. 6 into 3 minus 8. What's that? That's plus 10. That's a positive number. Since it's a positive number, we say it's a minimum point. It's a minimum point when x is 3 and y is minus 18. Okay. So negative second derivative means you have a maximum. Positive second derivative means you have a minimum point. All right, let's move on. Okay, now this is interesting. The derivative of 2ax raised to the power 7 plus 3x raised to the power k is this. We need to find the value of a and the value of k. Now, how do we think about this? They've given us the derivative and they've given us the original function. Let's say the original function is y equals 2ax raised to the power 7 plus 3x raised to the power k. Can we find the derivative of this ourselves? Let's find the derivative of this. 2a is just a constant. We will keep it as it is. Multiply by the power. So you multiply by 7. Subtract 1 from the power. X raised to the power 7 minus 1, that's 6. Plus 3 is a constant that remains as it is. You multiply by the power is k. And then you subtract 1 from the power, that becomes k minus 1. You simplify this and that gives you 14a x raised to the power 6 plus 3k x raised to the power k minus 1. That's the derivative that you're getting from this. Now, they have told us that the derivative is supposed to be 42x raised to the power 6 plus 15x raised to the power k minus 1. This is the derivative that we are getting, and this is the derivative that they told us. We can compare both of them. The coefficient of x raised to the power 6 that we have is 14a, and the coefficient of x power 6 that they gave us is 42. That means these two should be equal to each other. 14a should equal 42. 14 goes to the other side, gets divided. 42 over 14, that's 3. That's the value of a that we've got. Similarly, the coefficient of x raised to the power k minus 1 is 3k. In the derivative that we found, they gave us that this coefficient should be 15. Again, we can compare both of them. We can say 3k should equal 15. So the value of k is supposed to be 5. K turns out to be 5. All right. That's the value of k that we're getting. Make sense? Okay, let's move on. This is a bit blurred. Let's do this. A curve has this equation, y equals x cubed minus kx squared plus 1. When x is equal to 2, the gradient of the curve is 6. Gradient of the curve, remember, what do we understand from that? dy over dx. dy over dx is equal to 6. That's what they're saying. When x is equal to 2, when x is equal to 2, dy over dx is equal to 6. Okay, so that's the function that we have now. Y equals x cubed minus kx squared plus 1. That's the function. You can find the derivative of this, dy over dx, and see what that turns out to be. Derivative of x cubed, you multiply by the power, that becomes 3. Subtract 1 from the power, 3x squared, minus k as it is, and you multiply this by the power, it becomes 2k times x power 1. Derivative of the constant is just 0. Now, they have given us that when x is equal to 2, dy over dx is supposed to be 6. So we are not always going to put dy over dx equal to 0. In this case, the derivative, the dy over dx is supposed to be equal to 6, right? So we replace dy over dx with 6 here and replace x with 2. That gives us this equation, 3 into 2 squared minus 2k times 2 equals 6. Let's simplify this. We have 6 equals 3 into 4, that's 12, minus 4 times k. 4k equals 6. So I've taken 4k to the left side, 6 to the right side. That gives me this. And then k equals 6 over 4 or 1.5. That's what we wanted to show there. K equals 1.5 here. All right, let's move on. Okay, the graph of this function has two tangents with a gradient of 10. Find the equation of these two tangents. That's quite tricky. That's like 7 marks. That's a lot of marks. We need to find the equations of these two tangents. Now remember what we need to find. Tangent is a straight line. For a straight line, we need two things to be able to write down the equation. One is a point and the other is the gradient. Now, in this case, what they've done is that they've given us the gradient. They've given us that the gradient is equal to 10. Okay. So we know the gradients of both of these tangents. Both of these tangents have the same gradient, that's 10. Okay. But we do not know any point in this case. Points are not known. We don't know what points the tangents are made at. So we don't have those points. We have to find those points in this case. Now, how can we do that? The information that's given us that the tangents have a gradient of 10. Now think about it. If you have any curve, let's say you have some part of a curve that looks like this maybe. So this curve, it's a cubic curve. It'll actually be something like this. You don't necessarily need to know this, but just for understanding, let's assume it's a curve like this. So what's happening is there's some point here at which if you were to draw a tangent, they are saying the gradient of this tangent is what? It's equal to 10. If the gradient of the tangent is equal to 10, that means the gradient of the curve at this point, gradient of curve at this particular point, that is also equal to 10, right? Because tangent's gradient is supposed to be the same as the gradient of the curve. So whatever is the gradient of the tangent at that point, it will be the same as the gradient of the curve at that point. And that means since gradient of curves are found using differentiation, at this particular point, dy over dx is supposed to equal 10. So we can use this idea to find that point that we are looking for. Now, let me explain how to do this now. Y equals x cubed minus 5x squared plus 2x plus 8. First of all, we can find the derivative of this function dy over dx and see what that turns out to be. You multiply by the power, it becomes 3x cubed. Subtract one from the power, 3x squared. Multiply by the power again, that's minus 10. Subtract 1 from the power, that's minus 10x. Derivative of 2x, that will just be 2. Derivative of 8 is 0. Now, what we do is we put dy over dx equal to 10 to find those points that we're looking for. So we put this equal to 10 now, right? Because we're looking for the points where the gradient of the curve is equal to 10. 10 equals 3x squared minus 10x plus 2. And that gives us this quadratic equation 0 equals 3x squared minus 10x minus 8. Can we factorize this? 3 times 8 is 24. 12 and 2 should work. So we have 3x squared minus 12x plus 2x minus 8. 3x times x minus 4 plus 2 into x minus 4. That gives us two factors, 3x plus 2 into x minus 4. X equals minus 2 over 3 or x equals 4. These are the 2 points that we are looking for. We have to find the corresponding y coordinates as well now. Put these values back in the original function and see what the y values turned out to be. I am just going to write the y values directly. You should show working for this as well. So input these values there in that function, and you'll get some y values from that. Okay. Let me do this directly on my calculator. Minus 2 over 3 whole cube minus 5 times minus 2 over 3 whole squared plus 2 into minus 2 over 3 plus 8. You will have to show this working. Okay, and now this turns out to be 112 over 27. Okay, 112 over 27. That's the value that we're getting from this. For the other value, if we have x equal to 4 here, let's see what we get from that. Okay, x equals 4 gives us y equal to 0. So now we've got 2 points. One point at which we're finding the tangent is when x is equal to minus 2 over 3. Let me write down those 2 points here. So number 1 is a point minus 2 over 3 and 112 over 27. And the second point is 4 and 0. Gradients of both of them is 10, right? Both the tangents have gradient 10. Tangent 1 is passing through this point, and tangent 2 is passing through this point. Both of them have the same gradient of 10. What we can do is we can use y minus y1 equals m into x minus x1 to write down their equations. What about the first one? Y minus 112 over 27, right? Y minus y1 equals m, which is 10 into x minus 2 over 3. That becomes x plus 2 over 3. We want to convert this to y equals mx plus c form. Let's simplify this to that form. Y equals 10x plus 20 over 3. 10 into 2 is 20 divided by 3. And this term will go to the right side as well to give us 112 over 27. Okay. And now we can just put this on our calculator. Y equals 10x, 20 over 3 plus 112 divided by 27. It's on a calculator paper, so you can just do this directly on a calculator. That's giving me 292 over 27. That's the first equation. What about the second equation now? That has an easier point to work with. That's just 40. It's not a fraction. What is this going to be now? Again, y minus y1 equals m into x minus x1. Y minus 0 equals m, which is 10 into x minus 4. And that equation becomes y equals 10x minus 40. These are the two equations that we're getting. We say it's 10x plus 292 over 27 and 10x minus 40. These are the two tangents equations that we were looking for. All right, let's move on. Okay, now this one is relatively straightforward. Okay, let me look at this part C only. It's very similar to the one question that we did earlier as well, but I'll do it quickly. We have a function given and the derivative of this function given. We need to find the values of P and Q. P and Q. How do we do that? We can find our own derivative. Just differentiate this function. Multiply by the power. So it becomes 2p into x raised to the power p minus 1 plus multiply with the power here again. That's 2 times q. Subtract 1 from the power. 2 minus 1 is just 1. That's the derivative that we are getting. Okay. Now, the derivative that they gave us, that was 14x raised to the power 6 plus 6 times x. That was the derivative that they gave us. Now, we can compare both of them. That means 2q should equal 6, right? The coefficients of x should be the same. And these two coefficients should also be the same. You can either make these the same, or you can also say their powers should be the same. Both of them should give you the same result. You can try any of them. 2p equals 14, that gives you p equals 7. Or p minus 1 equals 6, that also gives you p equal to 7. So you can do any of them. So if I do p minus 1 equal to 6, that gives me p equal to 7. That's one answer that we were looking for. And then 2q equals 6, the value of q that we get is 3. These are the two answers that we're getting. P equals 7 and q equals 3. These are our final results. All right. Okay, one last question and then we end for today. The diagram shows a sketch of the graph. The diagram shows a sketch of the graph of y equals 4x cubed minus x raised to the power 4. The graph crosses the x-axis at the origin and at the point A. Okay, so you have this graph. Its sketch is given to you here. It crosses the x-axis at the origin and also at this point A. The point B is the maximum point. First of all, it's saying differentiate this function. 4x cubed minus x raised to the power 4. What's the derivative of this? You multiply by the power, it becomes 12, right? 3 times 4, that's 12. Subtract 1 from the powers, that's x squared. This is x raised to the power 4. You multiply by the power minus 4. Subtract 1 from the power, you get minus 4x cubed. That's the derivative. You can write that here. 12x squared minus 4x cubed. That's the derivative of this function. Okay, now that's the first part. Now it says, find the coordinates of B. Find the coordinates of B. Now let's look at that graph. What's the point B? B is the turning point or the stationary point. How do you find coordinates of a stationary point? You put dy over dx equal to 0, right? We know that dy over dx, we've already found that. That is equal to 12x squared minus 4x cubed. That's the derivative. You put this equal to 0 to find the stationary point. That gives you 12x squared minus 4x cubed. You can take 4x squared common. That leaves you with 3 minus x, which means either 4x squared equals 0. It's a product, right? That means either the first thing is equal to 0 or the second thing is equal to 0, or 3 minus x equals 0. The first one gives you x squared equal to 0 and then x equal to 0. The second one gives you x equal to 3. These are the x coordinates. Now, one of them is 0. Does the x coordinate of B look like 0? It's not. It's some positive value, right? 0 is this point. That's not what we're looking for. We're only looking for the point B. So we only consider the positive value. We say x is equal to 3. That's the x coordinate of B. Put that value of x back in the function and you'll get the corresponding y coordinate. Y equals 4 x cubed minus x raised to the power 4. So you can say it's 3 cubed minus 3 raised to the power 4. And that should give you the result. You can see what this is. 4 times 3 cubed, which is 27. Minus 3 raised to the power 4, that's 81. And that gives me 27. So the coordinates of this point are 3 and 27. These are the final answers. Then finally it says, find the gradient of the graph at the point A. Now, how do you find gradient of a curve? You find the derivative and put that particular value of x in that. What's point A? Point A is this point here. This is the x-intercept of the graph. It's the x-intercept of the graph. Do we know the value of x at this point? We don't. What we would have to do would be, we would have a derivative, dy over dx. We've already found that earlier. That's 12x squared minus 4x cubed. We can find the gradient at this point. If we know the value of x at that point, we would just input that value in the derivative, we would get the gradient. But the problem is we don't have that value of x. Okay, we don't know this value of x. But can we find it? It's a curve. A is the x-intercept of this curve. How do you find x-intercept of any function? You put y equal to 0, right? To find x-intercept of any function, you put y equal to 0. So what you can do here is you can say, let's put y equal to 0 first of all to find that point. Okay. The function y is 4x cubed minus x raised to the power 4. That's the function y. Now what we can do is we can say, let's put y equal to 0 y to find the point A. That's the x-intercept, right? And this gives us 0 equals 4x cubed minus x raised to the power 4. To take x cubed common, that leaves you with 4 minus x inside, which means either x cube equal to 0 or 4 minus x equal to 0. The first one gives you x equals 0. The second one gives you x equals 4. Again, x equals 0 is the origin point. That's not what we were looking for. We were looking for this point here. Sorry, this point here, the x-intercept, the other x-intercept. And that's x equal to 4. This is going to be the x-coordinate of A. Now, once we have the x-coordinate of A, all we have to do now is put this value of x in the derivative, because we're looking for the gradient of the graph, right? Gradient means the value of dy over dx at that particular point. In this derivative, you put x equal to 4. And what does that give you now? Dy over dx equals 12 into 4 squared minus 4 into 4 cubed. That will give you the gradient at this particular point. 12 into 4 squared, that is 16, minus 4 into 4 cubed, that's 64. You can put this whole thing on your calculator as it is as well. I'm just trying to make this quicker, since you are supposed to remember this as well, right? 4 cubed is 64. That gives me negative 64. That's the gradient of the curve at this particular point. It's minus 64, and that is our final answer. Okay. Any questions on this? No problems? Okay, so I hope that makes everything clear. That was differentiation. And that's this topic done, both in terms of concepts and practice. We've done a lot of practice on this. And that should cover every single type of question that you will see in the past papers. All right, so that's it for today. I'll see you again on Monday, inshallah. Allah Hafiz.